So finally, I'd like to invite Paul DeMarco, who is a Senior Director of Maple Development, to give us a guided tour of the Maple Programming Guide. Welcome, Paul.
Thank you. So for many years, the Maple Programming Guide was a published hard copy book. At some point, it was transcribed into a series of worksheets and made available in the help system. Of course, this was a huge improvement because all of the examples were then immediately available to execute, modify, and adapt. So I'm just going to go to the help system here. And you can find it under the manual section. And there's 3 manuals in the help system: the user manual, the programming guide, and the getting started with toolboxes. So I'm going to open the programming guide section. So the programming guide works both as a course and as a reference. I highly recommend it to anyone who wants to become more proficient at Maple to actually crack this open and read through it, which is what I did in preparation for this talk. I read it a couple of times, looking for a way that I could somehow condense it into a 10-minute talk, and it's just not possible, so you'll have to go look for yourself. The best I can do is show you some highlights, showing some concrete examples from the guide to show you that show up frequently in Maple programs and otherwise. So let's jump into chapter 3, for example. And as I said, these are all worksheets, so it jumps me out of the help system and back into Maple. Let's start with something like this. So Maple is a programming language that's designed for symbolic computing. And in order to properly support manipulation and evaluation of math expressions, it has some unique features. In some situations, it's necessary to delay evaluation of an expression. These right ticks are the unevaluation quotes. So the most basic example of this would show up in an example like this. So let's look at this example. So if I assign the variable output equals 2, and then I run this code generation output equals string command, I get an error. Because what's really happening here is it's passing 2 equals string, because this output is evaluating. So if I put quotes around there and then re-execute, now the code generation command is getting the proper option name. So let's look at evaluation and automatic simplification. So here's another example using uneval quotes, but when I execute this, I get 5. So it actually did evaluate. So there's a distinction in Maple between evaluation and simplification. So when Maple sees a data structure like this that is so simple, in its formulation of the data structure, it actually just adds those 2 numbers. So there's no way to get this expression by itself. But there are workarounds. There's other data structures that can be equivalent. So you could do 2% plus 3. And sorry, yeah. And that will give you this data structure that looks like a 2 plus 3. And I can take value of that in order to cause it to evaluate. Let's scan down a little bit to maybe this section. And for many years, I've been a kernel developer in Maple. And so this kind of thing is what the kernel sees as the data structure. So I won't go through this example in any detail. I just will note that this is the representation of a product. This is a representation of a sum. We uniquify references to everything. So you'll see that this is pointing to the same name A. And if you were watching Dave's talk, you can read the section to find out more about the subs-op and things like that. I'm going to go back to the help system and skip right to the end. There's an appendix that shows all of the underlying kernel data structures and describes them. Let's see this section. So for example, let's find that product. And it just describes what the components are of a product. We have an expression to the exponent, and then there's an implicit times between the next expression and the next exponent. And we have some optimized versions of products and sums. This is for specific to polynomials and is a tighter representation. Okay, so let's skip to the next section, basic data structures. And Darren did a great job of covering the mutable data structures. This section talks about both of those. There's some other core data structures in Maple, and then there's lots of compound data structures that show up that are built on top of the core data structures. Let's see. So just a comment on the structure of the programming guide. Every chapter has a section on avoiding common problems. And every chapter has a section with some exercises. And I highly recommend at least reading over the exercises. You don't have to do them, but when you read a chapter, the kind of test of whether you really understood the material is to think in your head about the exercise questions, read them over, figure out how you would approach that. And if you're not sure, maybe there's something missing that you need to go back and reread. So let's look at Maple statements. And I'm going to open the flow control section and loops. So there are several variations of loops in Maple. And there's pros and cons as to which one you'd want to use in what situation. When I can, I like to use the variable in container structure of the for loop so that it doesn't have to. So when you use a for I from, and then you index into, say, an array, there's an extra cost of formulating that index and then following the index to the entry. Whereas if you use this form, you just get all of the elements one by one by one. You don't have to formulate that index. And there's another specialized loop that I use every once in a while, and it's the exact right thing to do. So there's situations where you want to run the code at least once. And if you use just a regular while loop, you kind of have to do that one iteration and then start the loop or check if you're on iteration one, and do something special. The do until loop checks the condition after it's run at least once, and that can be useful in a bunch of situations. Let's look at procedures. So Maple has like an absolutely crazy, powerful set of instructions for declaring parameters in a procedure. You can read all about it in here. I'll just show you one very simple one that comes up a lot. So here's a procedure that takes X as a float and assigns it to a value. And then there's this special thing at the end. And that means that that's the end of all my parameter declarations. Otherwise, Maple allows you to pass in as many arguments as you want, and it can use things like args or nargs to find out how many were passed. So in this case, if I pass exactly one, I get the right answer. If I pass no arguments, I get the default value. And if I pass more than one argument, I get an error telling me I've supplied too many or the wrong type of arguments. And then it shows me which argument was the problem. Let's go back to the help. Just a quick note on here. Let's see. More about. So did you know that Maple has 5 different rounding modes, and these match what's specified in IEEE 754 standard? And also that Maple distinguishes between +0 and -0 when necessary. And this is actually very important for handling numeric evaluation precisely. Let's go back. I'll pick up chapter 8, and maybe I'll open up 8.4. I'm not going to get into modules. Modules are like classes as defined. Module and class are standard programming constructs where you can encapsulate both data and methods, procedures. I'll just open up the special exports. If you're familiar with modules and you want to take it to the next level, there's some special module exports that let you do interesting things like control how the module displays, load things, hook into a for loop, or treat the module as if it was a procedure so that it's callable. Let's go to, how about writing packages? Packages are great for sharing code. They're also great for reusing your own small custom tools that you created over the years. Which one do I want to open? How about this one? Once you've created a procedure or a module or a package, you want to be able to save it and share it. And a good way to do that is through MLA files. And we call these libraries. And Maple's main math library is stored in this format as well. So you can create your own versions of these, and then you have them to reuse in other worksheets or share with other people. How about the section on graphics?
2 minutes.
This one is large and it takes a little bit of time to load. There's lots of great plots in here. I'll just show maybe this one and this one. So I've never done this in my life, but I saw this example and thought it was really cool. So this is how to take an image and throw it onto a 3D surface. That's a roller coaster image. That's pretty crazy. So programming interactive elements, we've seen a little bit of this touched on. These are sliders, buttons, other kind of worksheet elements that you can insert into your worksheet, so you can create a custom interface that makes it easier for someone else to use the code, or even yourself if you want to create a tool. So let's see. So this table, I think we've seen this in some of the other talks. So I'm going to create a random matrix. If I executed those commands, I could create this table and its and it's all input here. I can edit these expressions.
Okay, we're almost out of time, Paul.
All right, let me see. I'll just go to one more section. There's a class of programs or features that we put under the category of OpenMaple. And OpenMaple is the API that you would use if you wanted to connect to Maple's runtime engine from a language like C or Java or Basic or whatnot. We have an Excel plugin that's written in Visual Basic, and that uses OpenMaple to connect to the Maple engine and do computations. So you can do Maple computations in Excel. If you're a power user, this is a chapter you would like to use. Actually, I'm going to open one last one and parallel programming. And I'll just note that the grid package is probably misnamed because it originated as the grid toolbox, and then we brought some of the functionality back into Maple. But this is the thing that you would use to run multiple versions of Maple kernels at the same time and get parallel evaluations, which is local distributed computation as opposed to threaded computation. But that's something definitely worth looking at.